Hello, this is a continuation for 8.1p task where we explore graph algorithms for connectivity and finding the shortest path using BFS and TFS. So in the first task, we use BFS for all the edges of one where it guarantees finding the shortest path. So we maintain and keep track of two things: the distance v, which is the shortest distance from S to B, and the count v, which is the number of the shortest path from S to B. So we initialize the distance equal to 0 and count S equals to 1. And for all the others, distance v equals to infinity and count v equals to 0 because we haven't explored any path yet. While performing BFS or exploring neighbors, we find a shorter spot, we update this value or the distance, and then we add it to the count. But if you find another distance, an alternative path that is shorter, we add it to the count. So this pseudocode explores that concept. So we initialize our BFS, and the distance itself is 0, so there's no way to put it so the count S is set to 1. So we are using Q for BFS, and where we include the source S to explore the shortest path. So while the Q is not empty, we GQ V and then explore each of its neighbors. So if a neighbor hasn't been visited, we update its distance and path count, then enqueue it. And if you find another shortest path to the node, then we add the number of the ways to the current node because we have found an alternative route to the same node. So in short, we find a shorter path to neighbor U, we update its distance and copy the path count. If it's an equally short path, we add to the count. Now in part B, where we explore the graph's connectivity, we use DFS for each node. If all the nodes are reachable, that means the graph is connected. So we began by creating an empty list to keep track of the visited node. This helps us to avoid revisiting the same nodes again and again. So our DFS function adds a node to the visited set, and then we recursively explore each node that has not been visited. Now we call DFS starting from any node. If the graph is connected, this one will eventually reach every node, and once done, we and once done, if the number of the visited nodes equals to the total number of the node, that means we have reached every node and the graph is connected. So to wrap up, the shortest path plus the count is the BFS, and TFS is the checks the connectivity of the graph.